Okay, so this is the 2023 Higher Level Leaving Cert Maths paper 1, and this is the last question on this paper, question 10. So let's see, we have a triangle. It has a base of length 2 units and a perpendicular height of 8 units, as shown in the diagram on the right. The diagrams below show T1, T2 and T3, the first 3 shapes in a sequence of shapes based on this triangle. For each value of n, which is natural, the shape Tn is made up of n rectangles of equal height laid on top of each other. Tn is the collection of the smallest such rectangles that completely cover the triangle. So we're given the first 3 terms here. 1 triangle and 1 rectangle, 1 big triangle and 2 rectangles, 1 big triangle and 3 rectangles. So draw T4 in the grid below based on the triangle given on the grid. So I've done that already here. Basically you have 4 rectangles. They're all of equal heights. We were told that in the question. Therefore, if the height of the triangle was 8, then each of these heights must be 2. So you just go up 2 squares or 2 rectangles here on the grid, go up another 2 here, go up another 2 here, another 2 here, and so on. So that's what it should look like. Now this second part, let's see, it says show that the total area of the 3 rectangles in T3 is 32 over 3 square units. Now I think there are a number of different ways of doing this. I'm going to do 2 ways. So we're looking at this one here. We've got to find the total area of the 3 rectangles in T3. We've got to show that the total area of the 3 rectangles is 32 over 3 square units. So the first way I'm going to do it is by looking at these little triangles here on the outside of the big triangle. These triangles on the outside are all congruent, and I'm not sure in the exam if they require you to show that, but if you did do this method, but I've done it over here anyway. I've done 2 of the triangles here. I've identified the angles and each of the vertices here. I've said angle 3 is equal to angle 6, so this angle here is equal to this angle here. Why? Because they're corresponding angles. Angle 2 and angle 5 are equal because they're 90 degrees, therefore the third angle must be equal as well, 1 and 4 angles in a triangle. But AB as well, this side here is going to be equal to this side here. We're given that in the question, we're told that in the question. So therefore by angle side angle, these 2 triangles are congruent. And it's the same for all the other triangles. All these triangles, these little triangles on the outside here, they're all congruent. So again, I'm not sure that it's necessary to do that, but anyway, it's done. So if you move these triangles down, let's say this one here, move the first one down, it's going to look something like that. Got rid of that. Take this one, move it down. It's going to do something like that. Take this one, move it down. It's going to look like this. So we've gotten rid of that one. And then take this one here, move that one down. That's going to look like that. So why am I doing that? Well, I've gotten rid of the triangles on the outside, so I'm just left with this triangle here, part of the big triangle. Now on the bottom here you've got 1, 2, 3, 4, 5, 6. There are actually 2 spaces here, 2 blank spaces if you like. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 triangles all congruent on the bottom. We have 1 here, 2, 3, 4, 5, and 6 here. We've got 6 of those triangles outside, in other words, outside the triangle. So that means the shaded regions here are going to be half of the area of this lower rectangle. So these little triangles, we have 1, 2, 3, 4, and then these 2 here. We have 6 of them. So those 6 small triangles represent half of the area of this lower rectangle. So if we take the area of the big triangle and add half the area of this lower rectangle, that'll give us the area of the three rectangles. That might take a little bit of thinking about, but that's basically what I'm going to do. Okay, so let's do that then. So the area of the big triangle is going to be half the base, which is 2, times the height, which is 8. So that'll give me 8 units. The area of the lower rectangle is going to be the base times the height. The base is 2. Now the height of this rectangle here at the bottom, remember you've got 3 rectangles, you've got 1, 2, 3, the height is 8, so the height of one of these rectangles is 8 over 3. 8 over 3, 8 over 3. So it's going to be 8 over 3, so that's 16 over 3. So we want half the area of this rectangle, which is multiplied by 2, so that's going to be 8 over 3. So what we want to do is add these two here together, and that'll give us the area of the 3 rectangles. So the area of the 3 rectangles is equal to 8 plus 8 over 3. So that'll give me, let's see, 8 over 1, 3, 1, 3 eighths, 24, plus 8, which is 32 over 3. I think that's what they said, yeah, 32 over 3 units squared. So that's it. That's the first way first method anyway that I did. Let's have a look at another way of doing this. Now, what I'm going to do is just have a look at this triangle here again. So I'm just going to copy it down. So I have it here. Now, if we have a look at this, the base of this triangle and rectangle at the bottom here is 2, and the height here is 8. So we know that that's 8 over 3. That's 8 over 3, and this is 8 over 3, the heights of these rectangles. So what I'm going to do is I'm going to have a look at working out this distance here. So these 3 should be the same. So if you imagine here, if we just take this distance down along here is 8, so I'm looking at this triangle here, so this is 8 down along here, so that's that distance there. This is 1 out to here, and I'm just going to work out this distance here using Pythagoras' theorem. So I'm working out the distance from there to there. I'm going to divide that by 3 just to work out this slope height, this slope here, and this slope here. So it's Pythagoras' theorem really. It's going to be 8 squared plus 1 squared is equal to, let's call it x squared. We'll call this x here. So that's 8 8 64 plus 1 is 65. So x is equal to the square root of 65. So that distance there is the square root of 65. Let's divide that by 3 then. Square root 65 over 3 is equal to one of these slant heights here, slant distances here, hypotenuses if you like. Let's just have a look at one of those little triangles then. So let's take one of these small triangles. So we know that that's 8 over 3 there. We've just worked out that that's the square root of 65 over 3. I want to work out the width here, because if I can work out this width here, I can work out the width of these rectangles. That's really what I want to do. So again, this is a right angle triangle, so I'm going to work out this here. Let's call this y. So let's do that. So we're going to take, again, it's just Pythagoras' theorem here, so we're going to take the square root of 65 over 3 all squared is going to be equal to y squared plus 8 over 3 squared. So we have the square root of 65 is 65 over 9. I'm going to bring this over, so that's 8 8 64 over 9. That's equal to y squared. So y squared is equal to 1 over 9. So that gives me y then is 1 over 3. So it's you kind of probably would have guessed that anyway, but this here, this distance from here to here is 1/3. This distance here is 1/3. So now we can work out the widths of each of these rectangles. We already know the height is 8 over 3. So we can now work out the widths. So let's do that. So the width of this first one here is going to be 2. We know that already. So let's just write down our area of the 3 rectangles. So the first one is 8 over 3 times 2. We know that. That's easy enough to do. So that's 8 over 3 times 2. What about this one here then? This one here is going to be 8 over 3 times this distance here. So what's that distance? Well, we know that that's 1/3. So from there to there is 1/3, from there to there is 1/3, from there to there is 1/3, from there to there is 1/3. So that's 1, 2, 3, 4/3. So that's our second one. So it's plus 8 over 3 times 4/3. And then the little rectangle on the top then is going to be 8 over 3 times 1/3, 2/3 times 2/3. So 8 over 3 times 2/3. So let's see, what does that give us? Let's see, 2 8, 16 over 3 plus 4 8, 32 over 9 plus 2 8, 16 over 9. That gives us 48 over 9 plus 32 over 9 plus 16 over 9. And if you add those, you get 48 plus 32 plus 16. That's 96 over 9. If you divide the top and the bottom by 3, you get 32 over 3, which is, I think, what they asked us to do. 32 over 3 square units. Okay, so that was two different ways of doing this. A tricky enough question, I think, but anyway, let's move on. Find the total area of n rectangles in Tn for n as an element of n. Give your answer in square units in terms of n in its simplest form. So the way I'm going to do this is to use the first method up here that we use, this method here. So I'm going to use this method here, which is the area of the big triangle plus half the area of the lower rectangle. Now, just to point out here that the heights of these rectangles here are going to follow a pattern, and that is, if you have 2 rectangles, then it's going to be 8 over 2. If you have 3 rectangles, then the height of each of these rectangles is 8 over 3. If you have 4 rectangles, the height of each rectangle is 8 over 4. So if you have n rectangles, the height of these rectangles is 8 over n. So that's what I'm going to use down here. So the total area of n rectangles in Tn, just to write it out properly, it's going to be half the base, so it's going to be half times 2 times a, half the base times the height, that's our big triangle, plus half the area of the lower rectangle. Well, the lower rectangle has a base of 2 and it has a height of 8 over n, the number of rectangles that we're talking about in any particular term. So this is just going to be 8 plus 8 over n, or we can just add those two fractions if you like and you get n. So that's 8n plus 8, or you can factorize out the 8. Anyway, that's our formula there if you like. Give your answer in square units, so this is units squared in its simplest form. I think that's, I mean, you can factorize that out. You can we put an or here, 8 bracket n plus 1 over n. Unit squared. Okay, next one then, different type of question, I think. Okay, the total area of the rectangle in the nth term of a different sequence of group of rectangles is as follows for n, which is natural. The total area an is equal to a times n minus 1 over n. Work out the first value of n for which an is greater than 95% of the area of the triangle on the right. Okay, so what we've got to do here is take our 8n minus 1 over n. That has to be greater than 95% of the area of the triangle on the right. The area of the triangle on the right is going to be half 2 times 8. So all you've got to do is work this out. So let's see, we've got 8n minus 8 over n bigger than 0.95 multiplied by 8. The half will cancel with the 2 here, give us 1 if you like. So you've got 38 over 5 on this side. Might just come over this direction. So the n is always going to be positive, and the 5 is obviously positive, so we can multiply across by 5n without changing this sign here. So on the left hand side we're going to get 40, n minus 40. On the right hand side we're going to get 38n. And let's see, just bring this over here, that'll give us 2n, and bring the 40 over, that'll give us 40. So that gives me n is going to be bigger than 20. So my answer then is 21. N has to be bigger than 20. So the next natural number bigger than 20 is 21. Okay, next part then. Part E. Diagram A below shows a square-based pyramid with base sides of length c. So we can see that here, and has a height of h here, perpendicular height of h. Diagram B shows the same pyramid. It also shows a horizontal square that lies within the pyramid. That's the shaded square in here. A distance of x units down from the top of the pyramid. X is real, x is between 0 and h. Now the area of the shaded square is given by this function here. So the area of this shaded square is given by c squared x squared over h squared. The volume of the pyramid is going to be the sum of all these areas here as x goes from 0 up to h. So you're going to take an infinite number, if you like, of these squares from here down to the base and add them all up using integration here. So use integration to find the volume of the pyramid in cubic units in terms of c and h. Okay, so a little bit of integration here, so let's do that. Now we want the integral from 0 to h. I'm going to put the c squared first and then the x squared, just switch it around a bit, and h squared, and we are integrating with respect to x. So that's going to be equal to, let's put all this in a little square bracket here. So we got c squared over h squared. They're constants, so they're going to remain the same. The x squared is going to become x cubed over 3. And we are integrating between 0 and h. So we got to put the h in first, so we get c squared h cubed over h squared times 3. If we put the 0 in here, all of this just becomes 0, so we're just going to subtract 0 there. Now, when we simplify this, we get c squared h over 3. These two here will cancel with 2 of those, and we just end up with h up there. Okay, so that's really it. That's the volume, so that's units cubed. C squared h over 3. I think that's all we were asked to do. Use integration to find the volume of the pyramid in cubic units in terms of c and h. Yep, that's fine. Okay, so let's have a look at the next question then. I think is over here. So x starts to increase at a rate of 3 units per second. X starts, so that means dx dt is equal to 3 units per second. This causes s of x to increase as well. That's the area of that shaded square. So in other words, as the square moves down the pyramid, the area of the square is going to increase. Find the rate of change of s of x. So we want d s of x dt. That's what we're looking for. That's this part of the sentence here. Find the rate of change of s of x with respect to time at the instant when x is half the perpendicular height of the pyramid. Give your answer in square units per second in terms of c and h. Okay, so this is going to be d s of x over something, and we're going to have the dt here. We've got to multiply those two. So what am I going to put here and here then that kind of cancel, if you like, to leave us with this here? Well, we have dx dt, so it's going to be a dx Put a dx there. Look, we have that. We know that that's 3. So put the other dx here so that they cancel and we end up with this. Okay, so let's put in our values that we know. Well, we have dx dt, so we can put a 3 in here. Now dsx dx we don't know, so we've got to differentiate s of x. So let's do that. So we know that s of x is equal to c squared x squared over h squared. So we want ds of x dx. So what do? You bring the power down, so it's going to be 2 times c squared x over h squared. So that's going to be this value here. Let's substitute all those in. So we have 2c squared x over h squared times 3. Let's just simplify all of this. So 3 times 2, 6. We have a c squared, we have an x, and we have a h squared. Okay, so what was the actual question then? It says, find the rate of change of s of x with respect to time at the instant when x is half the perpendicular height of the pyramid. X is half the perpendicular height. So that means it will be down around here somewhere. So that just means x is going to be half h. X is going to be half h. So when x is equal to h over 2, that means our ds of x dt is going to be equal to 6 times c squared h over 2 over h squared. So let's just simplify all of this. So we have 6 divided by 2, which is 3, c squared h over h squared. That'll give me 3c squared over h. That will cancel with one of these. 3c squared over h, and this is the rate of change. This is the rate of change with respect to time of s of x. So your answer then is going to be in square units per second. So it's going to be units squared per second. And that's it, in fact, for this question and this paper.